Alright folks, we're going to do ionic naming, putting it all together. I'll warn you, this thing's only 6 slides long, so it happens quickly. Alright, so please focus. When we put it together, you have to be able to identify cations that are in the main block, transition metals, cations and anions are in the main block, transition metals, and polyatomic ions. Why are we drilling this so much? It's because for the rest of the year, everything you learn is going to be based on this stuff. You have to be able to take a name and turn it into a compound and vice versa. All the time, all year. So this is stuff you can't forget. So we're drilling it and drilling it and drilling it to make sure you get it in your head of how to do this. You have to be able to do it quickly. Okay. So, looking at all of these, you have to be able to take these from names to compounds. All of this is review. You've seen it in the last 3 podcasts. See if you can do it on your own, then come back to me. All right. Magnesium hydroxide. So, magnesium is Mg. Hydroxide is OH. Magnesium is 2+. Hydroxide is 1-. So I need to crisscross, which means I need 2 hydroxides and 1 magnesium. Please do not do that. You need to have 2 hydroxides. That's the most common mistakes I have seen people make. Right? Magnesium hydroxide, you need to have the OH inside parentheses. Right? Magnesium peroxide. Peroxide is O2. It's not O, it's O2. It is a thing. You may not break it up. You do not have permission to break it up. Right? Magnesium is a 2+ charge. Peroxide is a 2- charge. How do I know that? Because it's on your ion chart. Okay? So since they cancel each other out, we're done. Manganese. Please make sure you do not confuse this with magnesium. This is manganese, and it's sulfate, so that's SO4. And manganese has a 2+ charge, and sulfate has a 2- charge, so they cancel each other out. Manganese sulfite. Be very, very careful. Then 8 versus ite is important. Sulfite is SO3. Manganese is a 3+ charge. How do I know that? It's because it tells me. And sulfite is the same as sulfate, so it has a 2- charge. When I cross them, I need to have 2 manganese, and I need to have 3 sulfites. I can't say S309 or I can't say S3033 without the parentheses. That's the way you have to write it. All right, give it a shot. See if you can do this. Pause the video, do them on your own. Okay, what I told you in previous podcasts, the way I do this is I write down NH4, which is ammonium. I write down peroxide, which is O2. Then I go back and I check my charges, which are 1+ and 2-, which means I need 2 ammoniums. So I have to put ammonium inside parentheses and I have to have a 2. And again, you're real tempted to say, I'm going to have NH4O. That is not correct, folks, because peroxide is a thing. So you may not change that. So it is NH4, parentheses 2, O2. Nickel 3 carbonate. Right? Well, that's nickel. And carbonate is CO3. And carbonate has a 2- charge. How do I know that? Because it's one of the ones you had to memorize. Right? Did you memorize it? If you didn't, go back and memorize it, please. Carbonate is something you need to know. All right, so my charges can't be lowered. It's a 3-to-2 ratio, so I have to have 2 nickels when I crisscross them, and I have to have 3 carbonates. Right, iron 2 phosphite. Well, that's not phosphide, it's phosphite. So iron is Fe, phosphite is PO3, and phosphite has the same charge as phosphate, which is 3-, and iron has 2+, so I need to have 3 irons, and I need to have 2 phosphites. Alright, how about the last one? Zinc. This is zinc, which is Zn, and thiocyanate you have to look up, which is SCN. That's on your ion chart. And then you say, well, that's 2+, and thiocyanate is 1-. I don't expect you to memorize that. You should be able to look it up. And then you realize that you have to have 2 of them when I crisscross. So again, you must put the parentheses around the thiocyanate ion. All right, how about going the other way? Right, this way's a little bit harder. So again, pause the video, try and do it on your own first, because you should know how to do this. All right, this is nickel, and this is PO4 is phosphate. Am I done? Well, nickel's a transition metal, so that means I have to check my charges. Right, well, phosphate is always and I have one of each one. Right, so that means I should have a 1 plus and a 1 minus. Does phosphate take on a 1 minus charge? It certainly does not. That should be a 3 minus, which means this has to be a 3 plus. And nickel, if I look at nickel, it is a transition metal, and it does have a Roman numeral 3 charge. How about this one? Well, this is nickel and sulfate, and I already know I have to go look at my charges. So I have a 2 minus. This is a 1-to-1 relationship, but sulfate takes on a 2 minus charge. So that means my nickel has to be a 2 plus charge. So this has to be nickel 2 sulfate. All right, how about this one? Can you do them? Again, pause the video whenever you feel you can to do them on your own. You have to learn to do them. All right, this is chromium, and it's borate. And when I do my crisscross, that's a 2 plus and a 3 minus. Does borate take on 3 minus? It sure does. So this is chromium. Do I need to put a 2 there? Well, again, just pick up your handy-dandy ion chart and look for chromium. And if you find chromium, and it says that it's chromium 2, then yeah, you have to put the chromium 2 there because it's a transition metal. There are only a few of them you don't have to do that with. All right, how about this one? Okay, this is clearly lead sulfate. Do I need to put something inside parentheses? I do. But I look at my sulfate ion first and notice it's a 1 minus and said, nope, that's not possible. It's supposed to be a 2 minus, which means my lead has to be a 4 plus. Right? So this has to be lead 4 sulfate. All right, again, pause the video, see if you can do them. All right, this is tin, and the MnO4, I look up on my ion chart, and it's permanganate. And do I have things in parentheses for tin? I sure do. So tin has to be a 4 plus, and this has to be a 1 minus. Does permanganate take on a 1 minus? It does. So tin takes on a 4 plus, so it's tin 4 permanganate. How about this one? Cobalt, and the HCO3, you have to look up HCO3, and it's bicarbonate. And do I have to put something inside parentheses? I do for cobalt. So I have a 2 plus and a 1 minus. Does bicarbonate take on a 1 minus? It certainly does. So cobalt is a 2 plus. How about your next one? This is cobalt. And PO3 is phosphite. I-T-E, phosphite. All right, and I already know I need something in parentheses. I have a 1-to-1 relationship. Right, that's a 1 plus and a 1 minus. But phosphite takes on a 3 minus charge. So cobalt must take on a 3 plus charge. That's cobalt 3 phosphite. What's this messy one? Well, this thing up here, that's ammonium. And Cr2O7, that's a pretty big thing, but if I look that up, that's dichromate. Dichromate. Now, do I need anything after my ammonium? I do not, because ammonium always takes on a 1 plus charge. There is nothing there. So let's see, that should be a 2 plus. That's, excuse me, a 2 minus. And a 1 plus. Does ammonium take on 1 plus? Yes. Does dichromate take on 2 minus? It sure does. So this all balances. So we're good. All right. have to be able to use the ion chart, balance charges from the chart, and correctly convert from names to compounds and compounds to names, which means you need to know the difference between when you find them as an alkali, the cations, as an alkali metal, alkaline earth metal, or aluminum, that you deal with them one way. You deal with them differently if they're transition metals. And on the anion side, if they're on the periodic table, they always end in IDE. And if they're not, you have to look at your ion chart, and you have to look up things like the eights and the ites, and even the per-eights and the hypoites. All right, that's it. Have a great day. Please work on the worksheets. Please do them all, and I'll see you in class. Bye.